Alright, hello guys. So today we're going to be looking at this problem, and in this problem the refrigerant is contained in a piston cylinder device at temperature T1 equals -12 degrees Celsius, P1 equals 0.2 megapascals, which is 200 kilopascals. The fluid is heated at constant pressure such that V2 equals 25 times what V1 was. The heat is then added at constant volume, so we know that V2 will equal V3 until the temperature reaches T3, which is 80 degrees Celsius. So A, it asks us the process on a TV diagram, and B, it asks what is H1, H2, and H3. So once we calculate H1, H2, H3, then we can draw the diagram. So over here I said that the schematic and givens, so there are three states. The first state mentions T1, P1, second state we're given V2, and the third state we're given the temperature. So my assumptions here is that this is a closed system, and also there's no heat loss, which means it's well isolated, and also assume that it's in a steady state. Okay, so here I started with state 1, and I mentioned the pressure and the temperature. From table A12 I got that T saturated, which is negative 10.09, is greater than T1, which was negative 12. So we know that this is going to be in the compressed liquid state. And also V1 we have, which is going to be 7.53 times 10 to the negative 4. This is also from the table A12. And A12 also gives us H1, which is 38.41. So we know the contents of the first state. Now we just need to go to the second state. The second state, as we know from the question, mentions that P2 is going to equal P1, which is 200 kilopascals. So then V2 is going to equal, or what we had as V1 times 25, which is going to be 0.0188 right here. So then also from table A12 we can see that UG is going to equal this, UF is going to equal this, and this is all going to be at this pressure, 200 kilopascals. So then from that we can use this formula to calculate X, and here's just the math for X. Okay, so then when we're done calculating X, we can find H, and we have H being calculated over here, and we get H2, which is 75.84. Okay, and then we go to our last state over here. So in the last state we know that V3 is going to equal V2, which is said to us in the question. And so we have V3 equals V2. From table A11 we have VF, VG. Okay, and from here we can actually see that V2, which is going to be greater than VG, we know it's a superheated vapor, then that means it's in the last state. So superheated vapor. Also we can have H3 from there, and that's basically it for the calculating H1, H2, H3. So we solve for all of the unknowns, and then for A over here then we have just the graph. So we can see over here this is state 1, which was at negative 12, and then we have this state 2, and actually this is supposed to just line up over here. So this is supposed to be over here, because over here we know that it's going to be the same volume. So over here, from here to here, we have the same volume. And this is volume, this is temperature, this is our graph. And we're done the problem. Thank you very much.